right, so section 3 is all about exponential functions. You see exponential in finance, so exponential growth like for savings accounts, because you start building interest upon interest, that's exponential growth. You also see it in biology, population growth, a lot of different places that you have exponential functions in the real world. Okay, so first let's take your graphing calculators. If you don't have it yet, just pause the video, get your graphing calculator. Okay, once you have your graphing calculator, what you're gonna do, we're gonna kind of just do some activities here for just a minute. What I want you to do is go to the upper left-hand gray button and it says y equals. Push the y equals. And you're going to clear what's ever there. And the first thing you're going to do, we're going to do this equation for 2, 3, and 5. So the first thing I want you to do is push 2 to the x in your y equals. So push 2, and then underneath the clear button on the very right-hand side, there's the little up arrow. That's how you get the x in the exponential function. Right next to the alpha green button is the xt theta n button. Use that for the x that goes in the exponent here. The next thing I want you to notice, they're giving you a viewing window right here. Okay, the second button, gray button from the left says window. Push that. It says x min, x max, and x scale. This is your x min, your x max. This is an interval notation, all right? So you want your x min to be -5. Use the negative on the very, very bottom right. X max is 5, and always do a scale of 1. Then this is going to be your y min, your y max, scale of 1. Push graph, which is the far right gray button. Okay. All right, so what do you see? I want you to kind of sketch what you see. Notice, if we were to make a table, you don't need to, but I just want you to see, if you plug in negative numbers for x, 2 to the -1 is 1/2. 2 to the 0, anything to the 0 is 1. 2 to the first, 2. So let's think about this. 1/2, 1, 2. Does that kind of follow your shape that you see? Notice there's not going to be a negative number that you can plug in for x in the table to get a negative y value. That's because there is an asymptote on the x-axis. All right, I'm going to want to see asymptotes for exponential graphs. Now, it always will have an asymptote along the x-axis unless there's a big fat plus or minus a number here. And we're going to see that in just a minute. Okay, but this is your 2 to the x. Now, go back to your y equals and do 3 to the x. Graph it. Notice this is a little bit lower. You won't be able to see it. It still crosses at the same spot because -1, 3 to the -1 is 1/3. A negative exponent, remember, that makes a reciprocal. That pushes the 3 to the bottom. Anything to the 0 is 1. And 3 to the first is 3. So this side's getting smaller quicker. This side's getting bigger quicker. I probably got a little big too quick, but now we're going to do 5 to the x. Back to your y equals, do 5 to the x. This is getting really, you can't even tell the difference now. But still, if you mark your asymptote on the x-axis, none of these will cross the x-axis. All right, so all exponential, I'm going to call this point right here the transition point. That's where it changes from getting really, really small to really, really big. Okay? All right, so that's just kind of a general lesson on exponential graphs. So I want us to let's look at this one without our calculator for a minute. Remember how I said if there's a big fat plus or minus, that's where your asymptotes are. So if it says -4, that's shifting your asymptote down to where y equals -4, down the x-axis to y equals -4. I think it's really helpful to always choose -1, 0, and 1 for exponential functions. Let's look at the transition point. The transition point will always be what makes the exponent 0, which in this case is 0. So 2 times 3 to the 0 minus 4. Anything to the 0 power is 1, times 2 is 2, minus 4, -2. All right, so let's think about what happens before the transition point. It's going to get really small. What happens after? It gets pretty big. Now, if you want to take your equation, clear out your graphing calculator, plug that in. As long as you've got your main, your asymptote, your transition point, and a sketch, that's going to be good for me. Okay, we're going to be using the calculators a few different times, so you definitely need it so I can help you learn how to understand how to use them. How about domain and range? All right, so for domain, it's going all the way to the left, because remember, we want left to right. It goes all the way to the left if I were to trace it. If I trace it, it's going to go all the way to the right. So my domain, -infinity to infinity. In general, your domain always starts with that. It's only if you have problems, things that are taken out of the domain, that it's not going to be -infinity to infinity. All right, how about the range? Notice it's approaching where y is -4, but it never gets to -4. So remember, you use a parenthesis if the number is not included. -4, then how far up does it go? All the way up will always be a positive infinity. That's your domain and range. All right. Finding the zeros graphically means using your grapher, your graphing calculator. So I want you to go ahead. Now, let's think about this first of all. What does this 5 do? That's a positive 5. I'm going to rewrite this as -2.5 to the x plus 5. This big fat plus or minus means that everything's shifted up 5. But what does this negative in front do? It takes this general and flips it down below. All right, so if I plug in 0 for my x here, I'm going to get 2.5 to the x, or 0, which is 1. This makes it -1, plus 5 is 4. Okay. So I'm going to flip that like this. That's going to be my general shape. And what they're asking, the 0 is your x-intercept. Another word for 0 is your x-intercept. All right, so you need to graph, clear everything out of your y equals, go back to y equals, plug in your equation, and graph it. Now, one thing that I think your viewing window from before should still work, but just let's go to zoom. Okay, so go ahead and push your graph, and you probably would see the correct graph, but push zoom, the middle gray button. Look at number 6, Z standard. Go ahead and push that 2 times, and that will always make your viewing window -10 to 10 from both X and Y. Now keep in mind, I'm throwing a lot of graphing calculator information at you. We will go over this throughout the whole year. We're going to constantly be going through this, so don't let it frazzle you. All right, so when you graph your equation, and hopefully you have something that looks similar to this, all right? Now, what we need to do is figure out where does the graph cross the x-axis. So you're going to push, here, I don't have mine. I need to get my graph put in. Okay, so in order to find this using your calculator, anytime you want your calculator to solve something on your graph, you're going to push the blue button, second trace, which is the 4th gray button. On the top it says Calc in blue. Notice number 2 says 0. You can either use your arrows and go down, or just push the number 2. Now, here's the important thing. In order for the calculator to find this, the first words it says along the bottom is left bound. You're going to use the left and right cursors to tell your calculator this is the left side before it crosses the x-axis, and you're going to hit enter. So enter it where it's above the x-axis, then use your cursor and go below and hit, for right bound, hit enter again so your y is negative, then push it for a 3rd time when it says guess. The guess doesn't matter, and it says at the bottom 0, x equals 1.7564. Remember, I said I always want 4 decimal places, and you just can chunk it. You don't have to worry about rounding. That's all you need to do. Okay. All right. I'm not going to wait too long on this particular part, so you might want to pause it if you're not comfortable with all your exponent rules. But if you multiply bases that are the same, you add the exponents. If you're dividing bases that are the same, you subtract the exponents. So whatever is the same stays the same. Notice in number 4, the exponent is the same, so it's almost like I'm factoring out the x as the exponent and putting AB inside. So you can go either direction. Sometimes you're going to go this direction where you're starting out this way, sometimes you go the other way. So just get all your, this is power to a power, so you're going to multiply. Write down all your exponents. Pause the video if you need to. It's also in your book. Okay, so not only can exponents grow, they can decay. All right, exponential decay is like radioactive decay in biology. It says, suppose a half-life of a certain radioactive substance is 20 days, and there are initially 5 grams present. So first, let's kind of try to understand what that's telling us. Okay. The initial is 5 grams. The half-life is 20 days. That means after 20 days, there's half of that, 5 halves. Take half of 5, you get 5 halves. After 40 days, there's half of that again, 5/4. All right? So think of it this way. We start with 5 times a half. We take 5, this is coming from 5 times a half times half again, which is 5 times 1/2 to the t. Now our time though, we have to be super careful about. This isn't after 2 days. This is after several time periods. So 20 days, 40 days. So we have to be kind of careful with our time here. All right. So typically what we do with this, we divide our time period by the half-life amount of days. This isn't, I'm just saying in general, this is kind of what we are going to use. Okay. So if our general equation is our initial times half each time, this says, when will there only be one remaining? I want you to always think of this number as the initial amount. And then when it does everything, this is going to be our final amount. Y is your final, X is your initial. Okay? When will we have just one remaining? Okay, so what you're going to do with this one's a little bit tougher with your graphing calculator. We're going to use, you can do this a couple of ways, but one thing I'm going to teach you, if you've got stuff on each side, if this is not Y, if this is a number, go to your graphing calculator, clear out all your Y equals. Make your first Y1 equal the left side, so I'm going to make it equal 1. Make your Y2, the next line down, equal the right side. 5 times, use parentheses, 1/2 raised to the t over 20. So it's going to graph this line. I'm going to come down here. So Y equals 1 is just a straight line going like this. Okay. Then this is going to get something like that. Now, here's the thing. We've got to figure out where that Y equals 1, this is my x-axis, this is really poorly drawn, sorry. This is 1. I've got to figure out how far along the x-axis, I've got to find where it intersects. Now, I'm just going to tell you in order to kind of get things going, I want you to go to your window. So go push the middle gray button. We're going to go x min of 0, x max of 50, and the scale, we're going to go by 10. So I'm going to go 10, 20, 30, 40, 50. Okay, that's kind of badly drawn, but you can work with me here. Okay, so we want to find the intersection point. So remember, when you want the calculator to find something for you, you're going to go second, calculate. Number 5 is the intersection button. So you're going to push intersect. Now, you could have graphs that intersect in multiple places, so it will always ask you which intersection point you want. So your goal is you want to just move the cursor to be close to this intersection point. Then, kind of hit enter a few times, and you should hopefully get 46.4385. Okay. So that's when the graph up here, this is when this graph will have 1 gram remaining in approximately 46 remember, you can pause this and absorb this. We can talk through this again as much as you need. Just jot down if there's stuff you want to go back over with me. And the calculator we'll use a lot, so you'll get a lot better at using it. So don't worry too much about the calculator. All right, so we define exponential functions, growth and decay, as y equals k a to the x. All right, a to the x, x is the exponent for exponential growth. Now, if a is greater than 1, it's growth. If a is between 0 and 1, it's decay. The compound interest formula, I'm going to call that A equals P times 1 plus R over N, all raised to the NT. This is in your book if you can't see this so well. N is the number of times per year, T is in years, R is the rate. All right, so our last example wants to calculate, say that you deposit $2,500, so that's our P. The rate, we always turn percents into a decimal, 0.054. T is 10 years. Now our N is going to change accordingly for each ABC. For letter A, N equals once. Annually is once a year. So A equals P, write it all out, times 1 plus the rate divided by 1, so it's just the rate, to the N times T. 1 times 10 is just 10. So you're going to add this first, raise it to the 10th power, take it times 2,500, and you should get 4230. Since this is in dollars and cents, I'm going to leave it as 0.06 for 6 cents. You want to round it to the nearest cent. Let's see what happens when we change this to quarterly. Quarterly means 4 times a year, so N is 4. A equals 2,500 times 1 plus the rate, 0.054, divided by 4 this time, because remember, N is 4, raised to the 4 times 10. I'm just going to multiply that in my head so I don't have extra stuff to do, and that's going to be 40. What's really important, order of operations. Do what's inside the parentheses first, then raise it to the 40th, and then times 2,500. If you're really good at this, you could actually enter all of this straight into your calculator as long as it looks exactly like this. And the calculator will just do all your math for you. And you should get 4274.55. Okay. I will tell you, if you want to do a fraction on your calculator, this is going to be really handy. You don't have to do it here necessarily. But if you push in this spot before you enter the numbers, the green alpha y equals, and it has N over D, it will create a fraction that you can use. We're going to use that a lot this year. All right, last problem. Letter C, monthly, means that N is 12 times a year. So I'm really doing everything the same. I'm just changing my N each time. So now every place I had a 4 the last time is going to be 12. And this I'm just going to multiply 12 times 10 for my exponent to get 120. Add everything in to your calculator. And notice each time as N goes up, the amount of money slightly goes up. So this is slightly higher than 4 times a year, which is slightly higher than once a year. So anytime you can get it compounded more quickly, your money will grow faster.